Lesson 13.5 is writing right Riemann sums as a summation. This is kind of guided because they set up these parentheses in the notation for you, but other than that, it's still you figuring it out, basically. So we're always doing a right Riemann sum. That's going to make a little bit of a difference in knowing what you're trying to find, but it will hopefully make sense. So we've got this curved function here. Our goal is we're trying to approximate the area under the curve by breaking it up into rectangles that are all the same width. So that's going to be our change in our x values. And they're going to tell us what they want us to find it from, 0 to 2, and that's where it goes. And they want it divided into 20 subintervals or 20 little rectangles. So this, we learned, means we're summing something up. It's capital S in Greek. Okay, and so we've got that K is 1. That means for the first rectangle, they want us to do 20 rectangles. So that's where the 20 goes. So this is always your total number of rectangles. Okay, the next thing that I find is the easiest to figure out is your change in x, your delta x. How wide, so I'm going to also put this as your width. How wide are your rectangles? And that's going to go here, not as part of your function, but we'll then use it for this part. So your change in x or your width is found by taking your b minus your a and then divided by your number of rectangles. So in this case, we're going 2 minus 0. That's the x values we're covering, and we're going to divide it by 20 rectangles. Well, that's 2/20ths or 1/10. You can put it in as a fraction or a decimal. I'm probably going to leave it as a fraction since that's what they do. All right, so now the hard part. The hard part is finding the heights of a rectangle. So the first one, since it's a right Riemann sum, will be the height here at, if this is a 10th, that would be 0.1 right here, at a 10th. And then this one would be the height at 0.2. So what we need to call these are kth rectangles. So when I have my first rectangle, or k equals 1, I know that this is going to be a height of whatever f of 0.1 is, or 1/10. If I wanted to know my second rectangle, that would be having, okay, I'm at 0, that would be at 2/10. My next one would be at 0.3, so I need to know that when I plug in x is 0.3 or f of 3/10, what is that height? So this is your number of rectangle, this is the height at, okay. So what's happening here is every time we're multiplying by a 10th and we're starting at 0. So you might see where it's 0 plus a 10th, 0 plus 2/10, 0 plus 3/10. Well, k is going in here. So we would say that it's starting at 0 plus our change in every width of a rectangle, 1/10, k number of times. So if it's the first rectangle, it's 1/10. If it's a second rectangle, it's at 2/10. It's a third, it's 3/10. If it's the 11th rectangle, it's 11/10. Having 1/10, oh, you can't even see, having 1/10 multiple times tells me what to do. And so that is what's going to go in for f of x, how we find the y value at a specific x value. You can have the 0 or you don't have to, but I would write 1/10 times k as k over 10. If you want to put 0 with it, that's fine. And then this is part of the answer that I wanted to show you. And so they're literally showing that for rectangle number 1, to get the area, you've got to have your 1/10, which is the width, which we've got right here. And then the height there would be at 0 plus a 10th, which is a 10th. So it's a 10th, f of a 10th times a 10th. And we don't know the function, but apparently they do. They're plugging it in and getting the area. Well, this shows for all 20 rectangles, and I guess I accidentally left off the total. There should have been a total value of adding or summing up all of these rectangles. That's what we're trying to show is happening. So even here at the 20th rectangle, if this is K, 20 literally got plugged in for K to make 20 tenths, which is 2. So f of 2 would have been the height of that rectangle times the width of 1/10 would get you 4/10 for the total. We're going to do one more of these. And we've got a new function that we don't know what it is, but we see the curved. We're trying to find the area this time between 2 and 6 are our x values. So we're not starting at 0. That's going to make a slight difference in what we get plugged in. But we're still knowing that we've got 20 rectangles. So K represents the area of the first rectangle. We got to do it for 20 summations. 20 numbers are getting summed together. You can see it here in this table I added. And then I would find the change in x. How wide are our rectangles? And so that's going to be your B minus your A, 6 minus 2. So we're covering a span of 4 units. And we're having 20 rectangles. Well, that is 1/5. 1/5 is a decimal, it's 2/10, just so you know. But you can keep it 1/5 or you can keep it 0.2. It doesn't matter. Okay, and so then I need to figure out what my heights would be. This rectangle here, so K equals 1, would be saying that it's f of, I'm not starting at 0, I'm starting at 2, plus, would we say the width would be 1/5? So it'd be 2 plus 1/5. 2 1/5 is where this would be right here, and I would need the height to get the right Riemann sum, where the right side of the rectangle touches. If I wanted the second rectangle, I would have to have the y value when x is starting at 2, plus now I'm going to have 2 of those 1/5, right? That's 1, oh my goodness, 1/5, 1/5. So that'd be 2 of those 1/5 or 2/5. If K was 3, I would have f of, starting at 2 again, plus 3 of those 1/5, so 3/5. So every time K is going in as the numerator. And so to find what needs to go in here, it's literally going to be your starting value, which is your A. So we're starting at 2, plus your change in x, which is the width, times K. How many of those widths are happening for each rectangle? So in this problem, I would have that it's f of 2 plus 1/5 for K rectangles, however many. If it's the first, it's only 1. If it's the second, it's 2/5. 3 is 3/5. And so I'd simplify that and say that's 2 plus K fifths. That's what needs to go into right here. I just want it to make sense, though, of what you're trying to do, because I find all the different variables are very confusing. So we're summing up all the areas instead of having area, 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 area. Summing up from the first rectangle to the 20th, every y value will be starting with x value of 2 plus width of 1/5, or 2/10, times whatever number rectangle it is, times the width is a 1/5. And then that summed up here, you can see this here, all 20 rectangles summed up to make 72.56. And so that is the second chunk of calculus, is finding area under curved functions.